Hello, everyone. I am hopefully sharing. I'm hopefully sharing my screen with you all. And let me get all set up to get started. Okay, here we go. Hi, my name is Whitney Welch. I am the lead instructional content specialist at iCEV. Thank you for joining me for meet and greet, getting up close and personal with iCEV's new STEM site. Hope you stick around after this session to join our live Q&A. Before I get started, just wanted to give you a quick overview of what I'm going to talk about in this presentation. I'm going to first talk a little bit about what the iCEV STEM site is and how we created it. I'll actually pull up the site and walk you through just a couple examples of the content we've created. And then I'll give you a brief overview of all of the curriculum that we have created for this school year. So for those of you who don't have any background information about iCEV, I'm just going to give a brief introduction to who we are. iCEV is an online-based multimedia curriculum publisher. We specialize in creating ready-to-teach CTE courses that are aligned to state and national standards. Our curriculum can be implemented in many different learning environments and offers flexibility and customization opportunities to help with differentiation for special populations or to meet whatever learning environment needs that you may have. Well, we do have an online platform that teachers and students can log into and use, but we also are able to be integrated into whatever current LMS you're using. That way you don't have to teach students how to use a whole new online resource. You can kind of utilize what they already know. Throughout the conference, there's going to be quite a few sessions giving you the opportunity to learn more about iCEV in general, or how to implement it or help your students get the most out of it. So if you're interested in learning more about iCEV in general, make sure to check out some of those sessions. I'm going to be talking about the STEM content in particular. So our iCEV STEM site will be brand new for this school year, and we're super excited to launch it. Before we got started creating content, we got a lot of feedback from STEM teachers about what they're looking for. We developed a series of 4 goals that we had for our STEM curriculum. So the first thing that we really wanted was for STEM to be accessible no matter what resources were available at a school or district. So we were super mindful of school resources when we designed projects and writing material lists. So outside of an iCEV subscription, you really don't need to purchase an additional kit or any extra technology to actually use our STEM curriculum in your classroom. Any of our material lists can be purchased for pretty reasonable costs from Amazon or Costco, or there are even some projects you can just do with your classes by just collecting recyclables throughout the year. Things like, pop bottles, popsicle sticks, all those kinds of things. However, on the opposite side of the spectrum, we know there are lots of schools that have awesome budgets and these huge, gorgeous maker spaces. So we didn't want to leave them out from our curriculum either. So all of our activities and materials can be completed with very few resources. And we've also created lots of options for extending the learning objectives past beyond those basic projects so that we can allow the students to utilize and explore the technology and resources that their school or district provides. So we really try to span to meet the needs of any school and what they have available to them in their STEM program. So another thing we heard a lot about from STEM teachers is how they would have to pull resources from all over the place to create their own curriculum. So this might be like maybe buying a kit for one unit, then watching a YouTube series for another unit and piecing their resources together. So one of our goals was to really be a one-stop shop. We wanted to be able to have a comprehensive curriculum where teachers could find everything that they need. So we provide enough content for teachers to cover year-long courses. We also provide lesson plans, assessments, vocabulary, even things like student notes that help simplify the lesson planning process so that STEM teachers can put their energy and their creativity into teaching and mentoring and coaching their students instead of just, having to chase down paperwork. Finally, STEM is, some teachers have said, kind of intimidating. There's a huge range of really expensive toys that can be very easily broken. And this can be frightening or, cause pause. So we enlisted the help of experts, including one of our content developers who's an MIT engineering graduate, to develop materials for not only students, but also for teachers about how to use STEM tools and technology so that the teachers feel prepared to take on whatever STEM tool or technology the students want. And we're going to continue, or the students want, or really the students have access to, really giving them the opportunity to utilize what their districts provide. So we're going to continue to develop these teacher resources and support systems throughout the year and as we continue to develop the STEM content. So with all of these goals in mind, we needed to get started creating the curriculum. And one of the first things we used to build our foundation of our content were educational standards. We pulled them from a couple different areas. First was from any states with their own standards for STEM CTE courses. We gathered all of that information. We gathered standards from the NGSS and ITEEA, like their STEL and technology literacy standards, and those helped guide our creation. The result was that we designed curriculum to be used with high school STEM courses, but we know that STEM is one of those areas where really it looks different at every school. So we also made sure that our content was really flexible so that you could use it in high schools or in extracurricular programs. So if you have a non-traditional STEM program, so it doesn't look like, a year-long course or even a semester-long course, if it's like an extracurricular program, it's a club, it's summer school, we are able to kind of meet some of those needs. So if you would like to learn more, you can always talk to one of the iCEV curriculum consultants or even myself about how you could implement iCEV in whatever your unique learning environment might be or whatever the uniqueness of your STEM program is. So that's just a brief kind of overview of what our creation process was when we were creating the STEM site. I'm now going to show you some of the content. I'm very excited. This is everybody's, like the public's first glance at STEM. So let's hopefully I'm sharing my computer screen where you can see the iCEV login page. I'm going to show you just a couple examples of our traditional lessons. First, I'm going to show you a PowerPoint lesson. Let this load for a second. So all of our lessons begin with some sort of direct instructional content. That instructional content may be presented in a PowerPoint like this one, or it might be a video. So I'll show you what a video looks like, and then I'll take you through all of the different supplemental materials that we include. So this is an example of a video. The direct instructional content is just going to be the first way that students are exposed to any of the content. This example here is part as a lesson that is part of a physics unit. It teaches all about kinematics in one-dimensional motion. In addition to the video or PowerPoints, some lessons may also have handouts as another method of providing direct instructional content. Student handouts are just like written text for students to read. In this case, this handout is about frames of reference and why those are important to consider when you're doing physics problems. Okay, so after you have all of the direct instructional content, we also provide activities and projects to allow students to engage with lesson objectives on a deeper level. So there's a couple examples I can show you for this lesson. The first one I'll show is an activity This activity is just a problem set to allow students to just get practice with doing the math that this type of physics requires. One of the nice things that we've done with all of our STEM content is whenever we have math problems like this, we provide the teachers with all of the work necessary to solve the problem instead of just providing the answer. This can be really helpful if you have students that need some help working through things, or even with accommodations and modifications. You might give them the written steps and have the students complete the math with those prompts. You have a lot of options when you get all the work written out. Another example of an activity is this fitness physics. It's all about having students go on a walk or a run and calculating their velocity and acceleration through this process. As you can see, there's opportunity for them to collect data and graph that data, all that kind of great stuff. And then projects. Projects tend to be a little bit more in depth. Usually it's trying to help students be creative, take their learning into their own hand, and really explore what they might be interested in, giving them some freedom to direct their learning. In this particular one, we're asking students to create proofs for the kinematic equations so they get to know more about what is the math? How do we know that these kinematic equations work and tell us what we need them to? So it's all directly connected closely to that direct instructional content for the lesson. So in addition to projects and activities, there are some other materials that just help support student learning. We have key concepts here. I can show you what those look like. These are just kind of our basic student notes that we provide. We use the Cornell note-taking strategy as kind of a inspiration for these notes. And they're super helpful to teach, to assist students in studying, and also just to teach some good note-taking strategies. So that's what that looks like. We also have things like vocabulary handouts and other types of things to help students study for to ensure that they understand all of the content. And then finally, we have assessments to really make sure that you can validate that the students have met their learning objectives. So this is just a printable version of what those assessments look like. Each of these items can be, all of these items here are available in PDF for you to download, so you can upload or send or print these materials and distribute them to your students however you need to. However, with student licenses, you can also have all of these activities and projects and assessments be completed online. So let me just show you an example of what these interactive pieces look like. For example, if we've got this is that fitness physics interactive lesson. What the interactive piece actually looks like is it's just it almost just looks like that assignment sheet, the PDF, except there's the ability for students to go in and actually enter the information. They can even graph things here as part of their answers. And the nice thing about having students turn this stuff in interactively is that they're doing the same work, but then you can access all of the work that they've done through our grade book. So you don't have a bunch of stray papers lying all over your desk that you need to grade. So that's always a plus, I think. I'll go back to the lesson page. I'll just show you what these assessments look like. We have some cool features on here for that. We have lots of different question types that we've implemented in the STEM stuff. So one of the big things, one of the big pluses, I think, in these assessments are we provide a the ability for students to use this scientific calculator. That way, you don't have to make sure that they remember to bring their calculators to class. They have it already in there, and so they can still take their assessments. Let me see if I can pull through or slide through a couple. There's lots of different question types that are available to assess these learning objectives. In addition to all of these, so that was kind of all of the materials that we have for students. We have the teacher lesson plan. This breaks down some of the goals, the objectives for this lesson. You could think of a lesson really as like a chapter in a textbook. It's not fully a unit, but like in particular, this lesson is 3 class periods worth of content. So it's kind of, kind of in between a unit and just one day's lesson plan. In your lesson plan, you've got your class, how we suggest, I guess, a suggested way to break down all of the content and the activities and projects. You also can get a sense of all of those activities and projects that we have listed and what they are requiring students to do. So you can kind of pick and choose from these descriptions if you want to use them. So then the final thing I'll show you in a lesson, in a traditional lesson, is this action plan. The action plan is just a student-facing version of the lesson plan. This is really helpful, especially in these STEM classes where you might be, where you might have students lead their own instruction. So you can just give them this action plan as their document of here's what you have to get done for this lesson. They can check off the steps as they go, and you don't necessarily need to lead them through all of the different steps. There are 2 new lesson types that we're introducing with our STEM content. Let me go back out to my courses page so I can show you what those look like. These 2 new content lesson types are lab challenges and design challenges, and they are meant to be more of unit law or unit, like they're meant to assess and practice learning objectives on a unit level rather than just a simple lesson level. So if I take a look at one of these lab challenges, the lab challenges are designed for students to do hands-on work, labs, experiments, all designed around the scientific method. So instead of direct instruction here, you actually have video instructions for completing a lab. There are teacher-facing instructions and also student-facing instructions. So as a teacher, you could watch this. You'll see all the materials that you'll need to gather, whatever pieces you might need to put together beforehand for your students before they begin the lab. Like, for example, if there's, some sort of secret chemical they need to test, we'll give you the instructions for how to set that up so that the students don't know answers or whatever. There's also instructions for the students in introducing what the concepts we're going to cover, the concepts covered by the lab challenge, lab procedures, how to collect data, all of that stuff in video form. This is really useful because you can have students watch it as a class. They're going to get all of their instructions. But then when they go into their lab groups to work on things, you don't have to answer the same questions. You can just point them back and they can watch those instructions as many times as they need. The instruction materials for lab challenges are pretty unique. One of the cooler parts of these types of lessons are the student lab reports. These are based, like I said, on the scientific method. So we have some background information that students will answer. They're writing hypotheses for research questions. There's the whole lab materials and procedures section, and then also opportunities for them to collect data and analyze that data, and then draw conclusions. All of that is available for any lab challenge. There is also a teacher instruction sheet that gives you the printed version of the video instructions. You have all of your objectives. You can learn more about lab materials, getting all of the lab prepped for your students. And we also have in-class instructions to help prompt students through what they need to create or to do. The other new lesson type are design challenges. These design challenges are similar. They're unit-based. They're assessing unit-based or unit learning objectives. Except in this case, it's not based on science principles. We're looking at the engineering design process. So these design challenges present students within some sort of engineering problem that they have to use the engineering design process to solve. So you have student introductions, you have teacher introductions and instructions, and even in some cases, testing procedures for how they're going to assess whether or not the prototypes they build to solve the problem function correctly. Other kind of helpful tips that we've created for design challenges are things like where we may not want to give, like an example is a hydraulics design challenge. We are asking students to create a hydraulic system. And the goal would be for those students to be able to test and kind of figure out some of the principles themselves without being led to the right answers. However, we create video helpful hints for teachers to say, oh, okay, this group is going to need a helpful hint. We'll show them a little more information about how to do this project. So again, we can scaffold based on student abilities, their background, even just time. If you don't have time for them to spend 3 days figuring out how to create a hydraulic system, you can give them some of those answers if you need to. The instructional materials are pretty unique for the design challenges as well. We have pre-challenge activities that help students review some of those unit-long learning objectives and really apply them to the challenge that they're going to be working on. We have a reflection projects so that students can take a look at how their designs changed and kind of present some of the information, the things that they learned throughout the design challenge. Those are super helpful to practice for any of the engineering design competitions. If you have students who are doing those, that's a great thing to utilize. The main piece of information or the main instructional material for these types of lessons are these engineering notebooks. So these are prompts to help the students work through solving these problems using that engineering design process. There's prompts for brainstorming. Students are asked lots of questions about prototyping. It gives them instructions for doing design reviews, prototype testing, all kinds of information. They're really useful documents that are are designed to help students really think about how are we solving our problems and how are we documenting everything that we do. Again, it's another thing that's going to be really useful if you're going to be applying to any kinds of engineering competitions, getting students thinking about these processes and these questions. So that's just your real quick overview of what the STEM content looks like. I'll go back to my PowerPoint now and finish up quickly here. So if all of this looks interesting to you, we're going to have the STEM site and the STEM curriculum available to you starting this fall semester. We also have introductory price offers, just so you know, for this first year. So make sure that you ask a curriculum consultant about that. Just so you know, our subscriptions are tied to a teacher and not a course. So that means if you're teaching multiple preps in STEM, like an engineering design and an engineering science course, you only need to have one subscription. You can have access to any of the STEM content. So kind of detailed out what we will have available for the fall. We're going to continue to add more content throughout the year. In addition to all of that direct instructional content, like I showed you, you have access to the printable lesson plans, projects, activities, assessments, any of those other things that I showed, the PDF versions, the printable versions. And if you add on the student subscriptions, you're also going to be able to use those interactive materials and assign and collect your activities and projects that way through the iCEV site or through your instructional or your learning management system. This is just a quick list of all the types of materials that I showed you in this lesson. I just put this in here so that you have a reference if you download this PowerPoint, so you have it with you, have it to look at. For this school year, we're launching with subject area playlists that are covering topics like scientific research and engineering science and engineering design procedures. So we're going to continue to develop course playlists to launch fall 2022. And we'll continue to add more content areas to the site. So if you teach a course that you don't see listed on the site, a STEM course specifically that you don't see listed on the site, but you are looking for curriculum, just let me know. I'll put my email at the end of the presentation. We'd love to hear what teachers are looking for so that we can help continue to meet teacher needs. So if the STEM site sounds interesting, check out our landing page, icevonline.com/STEM, and you can sign up to receive more information. Thanks so much, everyone, for joining my session. I really hope that everyone is as excited about the STEM stuff as we are. Just so you know, you're going to be automatically awarded points for attending the session. At the end of the conference, you will receive a digital certificate noting how many sessions you attend. And so now we're going to jump into our live Q&A. So if you have any questions for me about how we created STEM or, what to look for, you want to see that content, go ahead and ask me those questions. Thanks.